Look up at the night sky. On a clear night, away from city lights, you might see the breathtaking band of the Milky Way galaxy stretching across the heavens. For centuries, we've stared at those countless stars and wondered, are we alone? It's a question that has fueled our imagination, our science, and our deepest sense of curiosity. We used to think of our solar system as unique, a special little corner of the cosmos. But in just the last few decades, that picture has shattered. We've discovered that our galaxy is teeming with planets orbiting other stars. These are called exoplanets, and their discovery has launched one of the most exciting quests in human history, the search for another Earth. So, how do we find these distant worlds? It's not like we can just point a telescope and see them. Most exoplanets are incredibly small and faint, completely lost in the glare of their parent star. It's like trying to spot a firefly next to a giant searchlight from miles away. Astronomers had to get creative, developing ingenious methods to detect these hidden planets. One of the most successful techniques is called the transit method. Imagine a moth flying in front of a distant streetlight. As it passes, it blocks a tiny amount of the light. We see a slight, temporary dip in the light's brightness. That's exactly what happens when an exoplanet passes or transits in front of its star from our point of view. Powerful telescopes like Kepler and TESS stare at thousands of stars at once, waiting for these telltale dips in starlight. By measuring how much the light dims and how often it happens, we can figure out the planet's size and how long its year is. The more transits we see, the more confident we are that we've found a new world. Another powerful tool in our planet hunting arsenal is the radial velocity method, or the wobble method. It might sound a bit funny, but it's incredibly precise. Think about two dancers spinning around together. Even if one is much larger than the other, they both move. The larger dancer might just sway in place a little, pulled by the smaller one's momentum. It's the same with a star and its orbiting planet. The planet's gravity tugs on the star, causing it to wobble ever so slightly. We can't see this wobble directly, but we can detect it in the star's light. As the star wobbles towards us, its light waves get squished together, shifting towards the blue end of the spectrum. As it wobbles away, the light waves stretch out, shifting towards the red end. This is the Doppler effect, the same thing that makes a siren change pitch as it passes you. By analyzing these tiny shifts in the star's light, we can deduce the presence of an unseen planet and even estimate its mass. This method was actually used to confirm the very first exoplanet discovered orbiting a sun-like star, 51 Pegasi b, back in 1995. And what have we found with these amazing techniques? A truly bizarre and wonderful cosmic zoo. The universe, it turns out, is far more creative than we ever imagined. We found hot Jupiters, massive gas giants orbiting scorching hot, perilously close to their stars with years that last only a few Earth days. Their atmospheres are being blasted away into space, creating giant, comet-like tails. Then there are the super-Earths, planets that are bigger than Earth but smaller than Neptune. We don't have anything like them in our own solar system. Are they rocky worlds with thick atmospheres, or are they more like mini-Neptunes shrouded in gas? We're still trying to figure that out. We've seen planets made of diamond, planets where it rains glass sideways, and rogue planets that wander through interstellar space, untethered to any star. Each new discovery reveals another piece of the puzzle, showing us the incredible diversity of worlds that exist beyond our own. But among all these strange and exotic worlds, there is one type of planet that captures our imagination more than any other, a planet like our own. The holy grail of exoplanet hunting is to find a small, rocky planet orbiting its star in the habitable zone. This is sometimes called the Goldilocks zone because it is the region where conditions are just right, not too hot, not too cold for liquid water to exist on a planet's surface. And where there's liquid water, there's the potential for life as we know it. We've already found some tantalizing candidates. Take Kepler 186f, one of the first Earth-sized planets discovered in the habitable zone of another star. It orbits a cool red dwarf star much dimmer than our Sun. A sunset on Kepler 186f would likely be a shade of orange-red we can barely imagine. Then there's the incredible TRAPPIST-1 system, a star not much larger than Jupiter that hosts a family of 7 Earth-sized planets. At least 3 of them are squarely within the habitable zone, raising the mind-boggling possibility of multiple life-bearing worlds huddled around a single star. These discoveries are about more than just adding to a catalog of planets. They are fundamentally changing our place in the universe. We are moving from an era of speculation to an era of exploration. With new, more powerful observatories like the James Webb Space Telescope, we are beginning to study the atmospheres of these distant worlds. We're searching for biosignatures gases like oxygen, methane, and water vapor that could be a sign of biological activity. The search for life beyond Earth is no longer just science fiction. It's a real, observational science happening right now. Every new exoplanet we find is another lottery ticket in the cosmic grand prize. We don't know if we'll find simple microbes or something far more complex. But for the first time in history, we have the tools to ask the question and maybe, just maybe, get an answer. The next time you look up at the stars, remember that what you're seeing isn't just empty space. It's a vast ocean of possibilities, filled with countless worlds waiting to be discovered. The adventure is just beginning. Thanks for watching, and don't forget to subscribe for more journeys into the cosmos.